Solving quadratic equations, lesson 4, the quadratic formula. This lesson will focus on developing the quadratic formula, solving quadratic equations with the quadratic formula, using the discriminant to determine the nature of the roots of a quadratic equation, selecting the appropriate method to solve a quadratic equation, and then solving problems involving quadratic equations. When we use the complete the square method on various questions, we perform the same steps each time. If we perform those steps of completing the square on your standard form, ax squared plus bx plus c, and then solve for x, we end up with this formula. This is called the quadratic formula. It is a method or a shortcut that we can use to solve any quadratic equation. Solve 3x squared plus 5x minus 2 equals 0 with the quadratic formula. So let's start by rewriting our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In order to use the quadratic formula, we need to be able to identify what a, b, and c are equal to. A is always a number in front of our x squared term, so in this case it's 3. B is the number in front of our x term, or 5, and c is our constant, which is minus 2. We're then going to substitute those values into our quadratic formula. So I have negative b, our b is 5, plus or minus the square root of b squared, again b is 5, so 5 squared, minus 4 times a, which is 3, times c, which is negative 2. All of that is over 2 times a, so 2 times 3. Now we just need to simplify. So we end up with x equals negative 5 plus or minus the square root of 5 squared is 25. Negative 4 times 3 times 2 means we're adding 24. All over 2 times 3, which is 6. We have x equals negative 5 plus or minus the square root of 24 plus 25, or 49, all over 6. X is equal to negative 5 plus or minus the square root of 49 is 7, all over 6. At this point, I can look at the two equations that result. So from here, I can say that x is equal to negative 5 plus 7 over 6. Or I can say that x is equal to negative 5 minus 7 over 6. Solving those two equations, I end up with x equals negative 5 plus 7 is 2 divided by 6. This simplifies into 1/3. Our second equation, negative 5 minus 7 is negative 12 over 6. Negative 12 over 6 will simplify to negative 2. So there's my two possible solutions for this quadratic equation. Again, we could verify this question by substituting those values into our original equation and showing that both sides are equal. Let's try a couple more. This one tells us to go to the nearest hundredth. So in the end, we can accept an approximate answer. Example A is not written in standard form, so let's rewrite it. 9x squared plus 12x. I need to bring this negative 4 to the other side, so I'm going to add 4 equals 0. I now have that A is equal to 9, B is equal to 12, and C is equal to 4. When I substitute it into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, here's what we get. Negative b becomes negative 12 plus or minus the square root of 12 squared minus 4 times a, which is 9, times c, which is 4, all over 2 times a, and again a is 9. Simplifying, x equals negative 12 plus or minus. Under our square root sign, 12 squared is 144. 4 times 9 times 4 becomes minus 144. All over 2 times 9, or 18. This will simplify more. Root 144 minus root 144 is the square root of 0, or just 0. And so I have negative 12 over 18, which can be simplified to negative 2 over 3, or to the nearest hundred, x would be equal to negative 0.67. Let's go back up to the top and have a look at that other example. This one is written in standard form, so I can see that a is 5, b is negative 7. Sorry, let's try that again. And c is negative 1. Substituting into the quadratic formula, x equals negative b, which is negative 7, plus or minus the square root of b squared, so negative 7 squared, minus 4 times a, which is 5, times c, which is negative 1, all over 2 times a. We end up with x being equal to positive 7 plus or minus the square root of 7 squared is 49. 4 times 5 times negative 1 becomes plus 20, all over 2 times 5, or 10. We end up with x being equal to 7 plus or minus the square root of 69, all over 10. So we can look at exact answers. Our exact answers are that x is equal to 7 plus root 69 over 10, or x is equal to 7 minus root 69 over 10. We can also use our calculators and substitute those, or plug those numbers in, and we end up with x being approximately equal to 1.53, and x being approximately equal to negative 0.13. Now, an application question. A picture measures 30 centimeters by 21 centimeters. You crop the picture by removing strips of the same width from the top and one side of the picture. This reduces the area to 40% of the original area. Determine the width of the strips removed. So we started with this large picture that measured 30 by 21. And then we removed a piece from the top and a piece from one side. That piece that we removed has a width of W. That means that the inside here now has a length of 30 minus W, and the new side length is 21 minus W. Our original area was equal to 30 times 21, or 630 centimeters squared. Our new area Our question says, is 40% of that 630. To calculate 40%, we're going to multiply decimal 4 times 630, and we end up with a new area of 252 centimeters squared. This means that if I multiply, if area is length times width, my new area is 252. My new length is 30 minus the width that was removed. And my new width is 21 minus the width of the strip that was removed. Let's do some simplifying on this equation. I end up with 252 equals. Now I need to expand those two binomials. So I need to multiply 30 times 21, and we get 630. Negative w times 21, so minus 21w. I need to do 30 times negative w, so negative 30w. And lastly, negative w times negative w, or plus w squared. We're going to subtract 252 from both sides and do some combining of like terms. So on the left, we're left with 0. On the right, 630 minus 252 is 378. I can combine my negative 21 and negative 30w to get negative 51w plus w squared. I want to now solve for w. This is the same thing as solving for x in our quadratic formula. So let's substitute into the quadratic formula. So w on my quadratic formula will be equal to negative b, which in this case is negative 51, plus or minus the square root of b squared minus 4ac. Oops, sorry, that's my a. I should have rewritten that. A value is always the number in front of the w, so this should be 1 times c, which is 378, all over 2 times a. Remember, the square root sign goes all the way across. So I end up with w is equal to 51 plus or minus the square root. When I simplify under that square root, I end up with 1,089 all over 2. I can then simplify that out, and I get w equals 51 plus root 1,089 over 2, or w is equal to 51 minus root 1,089 all over 2. Solving my first equation gives me w equals 42. The second equation gives me w equals 9. This solution tells me that I removed a strip larger than what I originally started with, and so this one we can disregard. Means that the width of the strip that was removed was 9 centimeters. So my length started at 30, and then 9 centimeters was reduced. So 30 take away 9 is 21. My width of my picture started at 21, we subtracted 9, leaving me with a new width of 12 centimeters.